Hi, so we are back with my channel TechUnTex, and this time we're going to be working like very hard to upload a lot of videos and a lot of content. So in late 2022, I uploaded a video of how to install Nvidia Modulus on Google Colab. Now a few things have changed since then. Now Nvidia Modulus is finally open source, meaning that you can find Nvidia Modulus here on GitHub. It's pretty much like Nvidia Modulus, right? So you go to GitHub and you can find it, the repository. It's publicly accessible, which makes things easier. In the past, you had to do a lot of like weird stuff to get access to the GitLab repository. That's not applicable anymore. You can check out the peer reviews video, but it's not important anymore. Like, I'm going to make a new tutorial, this one, of how to install Nvidia Modulus on Google Colab in 2024. All right. So I'll tell you about this. What's Nvidia Modulus? It's an open source deep learning framework for building, training, and fine-tuning deep learning models using state-of-the-art physics ML methods, machine learning methods. In a way, you can abstract away how Nvidia Modulus works. Like, maybe you come from a background in which you have domain expertise about how to work with scientific computing and numerical methods, and that's okay. You don't have to exactly understand everything about how Nvidia Modulus works to use it, and that's what's exciting about it. Like, it's you can use it a little bit like a black box to a certain extent, in which you only define the problem setup, the parameters, like the boundary conditions and the data. In a way, you only need like the data, and even if you don't have all the physics of that problem, you can get the equations and the mathematical model that can describe it, and that's what's exciting about it. Anyway, this tutorial is about the installation, which can get a little complicated sometimes, but with Google Colab, it gets relatively easy. Okay, so first, I invite you, again, check out the Nvidia Modulus repo, which is this link, Nvidia/Modulus on GitHub. And it can get a little hard to actually find instructions to install it sometimes. I recommend you go here, Modulus documentation. It may sound a little obvious, but you'd be surprised. Okay, so yeah, so I open it in a new tab here, and then you go not here, like if you go here to documentation, in the documentation, like if you click Nvidia Modulus core latest release, you get all of these instructions about how to use Nvidia Modulus, but that's not what we want right now. So not here. You gotta go here, like Nvidia Modulus getting started, install and quick start guide, here in the quick links. This takes you to this page, which gives you the system requirements. I recommend you check out these recommended GPUs. We're going to be using the T4 on Google Colab in a moment. Now, they recommend using the Docker image, and in a future video, I would like to do this. I would like to do a tutorial about how to do this on Google Cloud, or on AWS, and on Azure, why not? But I'm not going to be focusing on how to do it with the Docker image. We're going to do it with pip install, the bare metal installation pretty much. We're going to install Nvidia Modulus on Google Colab with the pip install, and we're going to perhaps work around a couple of things to run one of the samples. We're also not going to run the sample here because it takes ages on Google Colab. I don't know why, but not all the samples are like that. We're going to run a different one, but let's just wait together. Okay, so the very first thing is okay, here, Modulus with pip install. Okay, pip install Nvidia Modulus, and let's see here. Okay, so on Google Colab you can install stuff like this, like !, pip install, and we have two packages. Now it's very easy. It's Nvidia Modulus and Nvidia Modulus sim. We could take this one out, I think, because we're not using it for the samples. That's actually very interesting. I forgot to mention that there are two repos. There's one that is like Nvidia Modulus, and there's another one that is symbolic. They there it's slightly different, but we're going to focus on models right now. Anyway, we can include it here, why not? It's the same thing, but we're really focusing on Nvidia Modulus, the core package, okay? So we run it, and let's see. So that should take like a very short second. You can see it's collecting Nvidia Modulus and Nvidia Modulus sim. Apparently it downloads NumPy again. I'm sure Google Colab already has it, but it seems that at some point even installs a version of NumPy and other packages and reinstalls like the version that it uses. I've tested it and it works fine. That's what we care about, right? Yeah, let's see. You're going to see that I mentioned. There's a lot of stuff. This is a very big library. It has abstracted away a lot of the complex neural networks and stuff, so that experts in different domains such as computational fluid dynamics, healthcare, weather, forecasting, a lot of stuff, like, you know, they can use the library and get insights from the simulations. This is why this library is so cool. And it takes a lot of learning in a lot of areas. Like, you gotta learn how to use the library itself, but also, obviously, if you want to leverage it, you have to know about giving a specific use case. And then on top of that, you gotta learn how to actually run it, the library. If the previous things were not enough things to learn, you also gotta learn how to run it. But this is what we're trying to do on this channel, to make it easier for you to run the library, Nvidia Modulus, and do scientific computing with the latest technologies and advancements in artificial intelligence, machine learning, etc. Okay. I'll probably speed this up when you're watching it, because it does take a while. It does take a little while. Many parameters. Could I show you examples perhaps? So in a moment we're going to click share examples, and as I mentioned, Nvidia Modulus, like, they have a lot of examples now, like computational fluid dynamics, weather, healthcare, molecular dynamics, and you know, it's hard to know about all this stuff. Most likely, many people from many different backgrounds are going to be learning a library like this. And in this channel, please comment below what kind of application you would like me to try to learn about and cover, because every application takes a little learning, of course. Okay. Yeah, it says this. Well, by the way, you have to restart the session because it asks you to do that. Oftentimes, Google Colab asks to do that when you install packages. Ignore this error. It complains a little bit about the versioning of libraries like NumPy and stuff, but you know, that's basic stuff. It works fine. It complains about these basic libraries, but it's okay. It works. So you can ignore that error message. Okay, so we go back here. We can test the installation running this code. Now, Google Colab doesn't exactly have a terminal, at least the free version doesn't. So, oh shoot, I forgot something very important. That's funny. Yeah, it's very important that you change the runtime type. You go to runtime, change runtime type, and you don't use the CPU, you use the T4 EPU. And that's going to delete our runtime, so I have to make the installation again. Sorry. Yeah, I'll pause the video for a moment. Oh, I have usage limits. Oh, that sucks. I have to use a different account. Okay, so I paused the video and now I'm back. I had to use a new account because of usage limits of Google Colab. I also had to make sure that first I go here to runtime and change runtime type, and I use the T4 GPU. If you're using the bed version of Colab, you can use better GPUs such as the A100 GPU. Okay, but anyway, so I already took care of that. Now I can verify the installation properly with this code that I took from here in the documentation, docs.nvidia/deep learning models getting started. Okay. Yeah, so it works. This verifies the installation, right? It has an output. Now, the best way to actually verify installation is with a by running an sample, right? So now it's very easy to clone the GitHub repository because it's actually public. In the past it was not, so as in my previous tutorial, but now it's very easy. Git clone github/nvidia/modulus. Okay, so we clone that and we're going to get it here. Okay, the repo with the samples and all the use cases. And the one I recommend is like this one, Darcy flow example. Now let's copy this just for a moment, okay? Okay, obviously I need exclamation marks here, and apparently you also need to take care of this library warp lang because it's not included in the modulus container, whatever. For a moment I won't include it, so just so you see what happens. You also can cd to the folder you need on Google Colab with this percentage sign. Now we're not going to do this example because it took more than an hour when I did it, and that's just too bad. In a future video we'll learn how to speed up Nvidia Modulus with multiple GPUs. Not right now, we only have one GPU. But we're going to run an example that takes much less to finish running, okay? So that example is going to be Navier Stokes flow, which is a classic example in scientific computing and computational fluid dynamics, right? So we're not going to study the example per se, we're just going to run it, but here you can find the references of this example. And what we need is the path, of course. So we're going to replace this path, right? You know, so it's going to be examples of Navier Stokes, right? And we also need a different command, right? We're going to run this one, right? Because it's a different Python file, okay? So yeah, so there we go. We try to run it, and it's going to complain. Well, oh, it's complaining about this one. I was hoping it was going to complain about warp, not 1dB. Anyway, that's okay. So we can install it. Pip install. It complains actually about a few packages. If it works out, you just install them. It's that easy. Okay, it's very fast too. Oh, by the way, now I'm running it again on the shell, but you know, you only need to do this once per cell, I think, on Google Colab. And okay, so yeah, I comment this out too because I already ran it once. But now it's also complaining about MLflow apparently, as you can see. You saw that? Okay. So we do pip install MLflow. That's fine. That's to be expected. Okay. Takes a few seconds. Okay, that was fast enough. Now we run it. Okay. It seems that this example doesn't complain about warp lang. I know that the example they have here of the Darcy flow example, this one does complain about not having this library installed. So you do have to run this perhaps for certain examples, but not all of them. So this example gets the data from a Google Drive apparently. Oh wow, I didn't run. Huh. I don't know how this worked because I didn't run. I didn't install GDown to download the stuff from Google Drive. So I assume Google Colab already has that. But this example that we're actually running does tell you that you know, like, GDown package is required because you know, like, to download the dataset from a Google Drive link apparently. But I guess Google Colab, and it makes sense, already has that one. So we didn't run that right now and it worked just fine. So it extracts the data, and there are a few steps here that I want to highlight once it gets there. You know, one of the big topics and we're going to cover that, is that it's slower than I wish it to be. So we're going to eventually be covering how to speed up NVIDIA models as much as possible. And the way to do that, obviously, is with more GPUs, more parallel processing. And for that, we're going to need Google Cloud. A dream I have is to actually start a company in which, TechContext makes this as easy as possible, like TechContext.com. Like, my dream is that we can have a company in which, this could be as easy as possible, because it's a pain. Scientific computing is a pain. It's super slow if you do it from your computer. It's very expensive and hard to set up if you use our cloud. So I'm thinking about first making it as easy as possible, and perhaps come with a model that it's also more affordable and easy to use, so that the experts in the different fields can just leverage scientific computing simulations to make technological, engineering, scientific advancements. So that's the goal. Warning, you're connected to GPU runtime but not utilizing the GPU. I suppose not yet, because this is supposed to obviously use the GPU. That's funny. Yeah, at some point it's going to get to the process in which you can see the loss function minimization per line. I want to get there before I pause the video. Okay, so now I should be starting to use GPU. Hopefully. As you go along with the simulation, you should see the output folder here. It's just getting started, but like it starts to put stuff here, eventually it's going to produce a series of images about the simulation, which are very cool. I want to show you. There you go. Okay, so it just got started. It's going to run for like 40 minutes. Last time I ran it ran like that, but you can see here, for example, like a learning rate, which is, I'm sure, not as important as the loss function, which I don't see yet. I'm sure we'll see it in a moment. Where is the loss function? Where is the loss function? It takes time. This is so slow. I know Google Colab is free, but maybe the paid version is worth it. But anyway, eventually we are going to have tutorials here about how to speed up this stuff, because it's very hard to learn how to use a library if it takes like 40 minutes to get the results for whatever you try. Okay, that's interesting. I don't see the loss function here. The measurement. I have it here too in another notebook. Let's check my old notebook. Yeah, this example doesn't show the loss function in the logs. Huh. I wonder why they did that. But most examples do show the log function in the logs. It's so important, right? You know what? My mistake. Is the validation error the loss function? Maybe, because this number is getting smaller, right? 3, 2, 1. Yeah, the validation error is probably the loss function here. It's the error, right? Let's ask ChatGPT, should we? Oh no, maybe not. Yeah, why not? Okay. Yeah, let's ask ChatGPT here, very fast. And why not? Do you think the validation error means the same as loss function? I was expecting to see function, but there's nothing about that. It's going to be interesting. It says that validation error and loss are related, but not always the same. The validation error reported in logs likely refers to a specific metric used to evaluate the model's performance on the validation dataset, right? Which is separate from the training data. Okay. This error could be any number of metrics, depending on the task, such as mean square error, accuracy, or any other relevant measure. The loss function, on the other hand, is what the model optimizes during training. Okay. It calculates the error between the predicted values and the actual values during training. Okay. And the model's parameters are updated to minimize the loss. Okay, so the loss function is like during training. Then, if the logs only mention the validation error and not the loss, it could be that the logs are specifically set up to report model performance metrics that are considered more interpretable or directly relevant for evaluation model quality during validation phases. However, the training loss is often low as well. That's what I was expecting, as it provides insights into how well the model is learning from the training dataset. It's possible that the loss during training is not being displayed in the provided logs, either due to the logging configuration or because it's assumed that the user is more interested in the validation metrics. Okay, yeah. So, yeah, it has the validation error, but it has a learning rate. So this confused me a little bit. What we know is that this example is running, but if you want to study the example more, and maybe I should do another video about this example in particular. In fact, I will. Anyway, if you want to check the example here on GitHub, here it is. It does say something about the sample uses 1,000 training samples and 10 test samples. Yeah. But I wonder why they didn't log the loss function. Because that's how Nvidia Modulus works. It minimizes the loss function. And then it shows the stuff. Anyway, I'm going to pause the video and we're going to see the output in the end. That's it. Okay, so it finished the training, as you can hear. It finished running, right? So, as you can hear, it took from minute 27 almost until 42. So, it's kind of like 15 minutes. Yeah, that's okay. I wonder if with a better GPU, like what you can see here, perhaps with the A100, it could be faster. We will be studying in the future how we can run Nvidia Modulus much faster with multiple GPUs. For that, we would probably need to set up a cloud instance with GPUs, perhaps something like a cluster. It can get more complicated, but in this channel we're going to be doing that. I'm not going to cover the output. We just can see that it finished training, which means that it worked. The library worked. You can see here, for example, a few output images. Open image and just have, then the last one, which is number 20, open in a new tab as well. You can see here how it completed the simulation. All of this can look like Chinese to me, because I don't know Chinese, but it can look like we don't know what we're talking about here. But if you want to understand the example, go here. Modulus examples, computational fluid dynamics, Navier Stokes. Here are all the references. In a future video, I would like to cover this, so let me know in the comments if you're interested. Excuse my dog, it's very unfortunate. Anyway, so that's it. Please support the channel. I'm going to do my best to upload a video every week. I would be very grateful if you can go to patreon.com/TechOnTechs and support the channel. You're going to get a lot of perks like early access to videos, but you can also talk to me and perhaps you can give me ideas. And I have a vision for the channel. I want to be this very educational across a lot of domains. I think this is really the time to do it, and I don't see a lot of people teaching this on YouTube for free in a way that is accessible and easy to understand. And I can't work for Nvidia. I live in Guatemala. I don't have the right to work in the US. It's complicated. So I would like to start something of my own. It's my dream, and I would appreciate the support from my community that is interested in scientific computing, and I'll be able to repay it to all of you with better tutorials and perhaps eventually a tool that you can use as well, a web interface in which you can deploy all of this scientific computing stuff. And if you support me now, I'm thinking how we can have discounts for my audience for that. So I would appreciate your support a lot. So thank you, and see you in the next video. Bye.